Hello and welcome back. Today's section is going to be section 3.1.5, which is addition rules of probabilities. Sometimes it so happens that you might want to find the probability of more than one event. Let's say you want to find the probability of eating an ice cream and getting an A in the class. Imagine if that was possible. How cool is that? Or let's say you want to find the probability of tossing a tail and raining. Now, these might seem very weird, but you might ask, Miss, why would somebody want to do that? You never know. You might want to find the probability of more than one event. So let's go ahead and look at the addition rule. In addition rule, which is addition of probabilities, if A and B are events defined on a sample space, then probability of A or B is simply probability of A plus probability of B minus probability of A and B. When I use the formula, yes, definitely it's going to be confusing, but when we work on the problems, it's going to be much easier. But the key word is, please make sure you write this down. The key word for addition is OR. So every time you see the word OR in probabilities, you know you are adding. So probability of A or B is simply probability of A plus probability of B minus probability of A and B. Now let's go ahead, take a look at examples. This is the first example. If the probability of a student spending time reading is 0.07, reading is 0.70. So the student is reading, the probability of a student reading is 0.70, which is 70%. Wow. I would like to have that student in my class. Probability of spending time watching TV is 0.10, which is 10%. What a lovely student he or she is. And the probability of spending time reading and watching TV is 0.01, which is 1%. What are they asking me? What is the probability of students spending time reading? The keyword is or watching TV. So they're asking me probability of students spending time reading or watching TV. I'm just going to put a W here, which is simply probability according to the formula, probability of reading plus probability of watching TV minus probability of reading and watching TV. So if I plug those values, probability of reading is 70% or 0.70. Probability of writing is 0.1, which is 10%, minus probability of reading and writing is 0.01. And when I find the value, my final value is 0.79. So 79% of the time, so I'm just going to undo this one. So 79.79, which is 79%. So 79% of the time, the student is either reading or watching TV. So your correct answer in decimal is 0.79. You don't have to give your answer in percentages, but I'm just giving it to you as a percentages so you can know that 0.79 is nothing but your 79%. Let's go ahead and take a look at the next problem here. If A and B are events with probability of A is 0.5, probability of B is 0.3, probability of A or B is 0.67, find the probability of A and B. In order to do that, let's go ahead and write down the formula first. Which color? Let me pick red. Okay, I'm just going to go with red. Actually, let me pick a blue. So I have so I have probability of A or B is simply probability of A. This is the formula we've been working with, right? Probability of B minus probability of A and B. So I'm going to go ahead and plug in all the information I have. Do I have A or B? Yes, I do. So 0.67 equal to, do I have probability of A? Yes, I do. 0.5 plus, do I have probability of B? Yes, I do. 0.3. Do I have probability of A and B? No, I don't. That's what I'm trying to find. Keep in mind. Oop, that's an and. So let me go ahead and add these two order of operations. So 0.67 is equal to 0.8 minus probability of A and B. So now I need to find probability of A and B. In order to do that, I simply subtract 0.8 from both sides. Subtract 0.8 from both sides. So what do I get? Cancel. I get negative 0.13 equal to positive, negative cancel each other minus probability of A and B. Both the negative signs cancel each other. What do I end up with? Probability of A and B is simply 0.13, and that is your final answer. The rest of your homework problems are simply based on this particular formula, which is probability of A plus probability of B minus probability of A and B. So I want you to go ahead and work on those problems. If you have any questions, again, email me or let me know through Teams. So the next topic in addition of probabilities is your complement. A complement of an event is that an event not occurring. So if I say probability of A is 25%, then the complement of A is 75%. Now, when I say this, you might ask, where did I get 75% from? So let me give you an example. What's the probability of you swimming today? Let's say probability of you going for a swim is 10%. What's the probability you are not going to go for a swim? Which is simply the opposite, which is 90%. Because together it has to add up to 100%. Let me give another example. Probability of how do I say that? Probability of the rain today, that it's going to rain today, is 40%. What's the probability it's not going to rain? Oops. Probability it's not going to rain is 60%. Do you see that? So when I add up the event and its complement, I should end up with 100. So now let's go ahead and take a look at the definitions. So the complement of an event A is that the event not occurring, and it's denoted by A and a hyphen on the top. Okay, together probability of A plus the complement should add up to a 1. So if I say probability of A is 0.25, then the complement is going to be 0.75. Remember, both of them should add up to a 100%, which is nothing but 1. So 1.00. Or you can say this is 25%, this is 75%. Together adds up to 100%. Do you see that? So if it's a percentage, it needs to add up to 100%, but if it's a value, it needs to add up to a 1. Now let's go ahead and take a look at the examples. Let's go ahead and read this problem first. It says, phones are collected from conferences are labeled 1 through 40. What is the probability that the conference speaker will choose a number that is not a multiple of 6? So phones are collected from conferences are labeled 1 through 40. So just to do that, let me go ahead and label them for you. So I have 1, 2, 3, 4, 5, 36, 37, 38, 39, 40. All right, now that I have labeled everything from 1 to 40, now let's go ahead and see what they're asking me. What is the probability that the conference speaker will choose a number that is not a multiple of 6? Now let me go ahead and see how many of them not multiples of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So the rest of the numbers, let me change the color to yellow. So this number 6, where is it? So number 6 is a multiple. Number 12 is a multiple, right? Number 18 is a multiple. Number 24 is a multiple. Number 30 is a multiple. Number 36 is a multiple. So these numbers are multiple. The rest of the numbers are not. So I have 34 numbers that are not multiples of 6. But what is my sample space? From 1 through 40, I have 40 numbers. So the probability is, remember the probability? How do I find the probability? Probability of not being a multiple of 6 is you start with your sample space. How many numbers do I have? 40. How many of them are not multiples of 6? 34. In its simplest form, 17 over 20. There you go. Now let's go ahead and take a look at the next problem. There are 26 cards in a hat. Each of them contains a different letter of the alphabet. If one card is chosen at random, what is the probability that is not between letters L and P inclusive? So let me go ahead and write those letters down so you can see. So I'm going to start with, let's say, where is my, okay, I'm going to start with A, B, C, D, E. Okay, I've written down all my letters. Now I'm trying to see what is the probability that it is not between letters L and P. Inclusive, that means I should not have the letter L all the way to P. So let me go ahead and strike those down. I'm going to change the color to stripe. So I cannot have L, I cannot have M, N, O, P. And the rest of the letters I can. So out of 26 letters, if I'm striking 1, 2, 3, 4, 5, how many do I have? I have 21 left, correct? So let me go ahead and find the probabilities. The probability of not choosing letters L through P is, again, I start with my sample size. How many letters do I have? 26. How many did I strike off? 5. That means the rest I can use, which is 21. They should not be L, M, and O, P. They can be anything from the rest, which is 21 options. All right? All right, let's look at this problem here now. The probability that a randomly chosen college student is up to date on vaccines is 0.42. Then what is the probability that the randomly chosen college student is not up to date? So keep in mind what they're asking me. They're asking me the complement. Remember, they're asking me the complement of the event. So probability of not up to date. What is up to date? 0.42. Not up to date is the opposite. It's like saying probability of it raining is 0.2. What's the probability of not raining? So to simply find the complement, what you do is 1 minus probability of up to date with the vaccines, which is simply 1 minus 0.42, which is 0.58. Your final answer. So remember, every time you're finding a complement, they both should add up to a 1. Or you simply subtract 1, you simply subtract that probability from 1 to get the other.